Hey, I'm here to talk about the last scenario of the ambiguous case for the law of sines. This is where you're going to get two triangles from the given information. All right, here's my rule. It says this: if the first angle you find is larger than the given angle, then there will always be two different triangles that can be formed from the given information. All right. Let's take a look at an example where this is the case. All right. Suppose I'm given this problem. It says solve the triangle, and I'm given that A equals 50 degrees, B equals a length of 15, and little a equals a length of 12. Okay. The first thing I'm going to do is draw my little triangle here. So let's draw a triangle, and it can be any triangle you want. All right. We're not sure about the specifications. I want to label this triangle A, B, and C. All right, just to get an idea of where we're going. I'm told that A is 50 degrees, so we'll label that. Little b is 15, so put a 15 down here, and little a is 12, so put him over here, right? Okay, now, looking at the scenario, I know I'm given an angle, a side, and a side. That's the angle, side, side scenario. Oh no, that's the ambiguous case. You always want to check that. There could be no triangles possible, there could be one triangle possible, or there could be two triangles possible. Okay? So let's take a look at this. To set this up, I start by writing the law of sines using the angle and his opposite side, the 50 and the 12. And the only thing that I can find first is that missing angle B. Okay? I can't find angle C or side C because neither of those pieces of information are given. All right? So let's set up the law of sines here. To solve for angle B, I would say that the sine of 50 degrees over 12 is equal to the sine of angle B over 15. All right, to solve for angle B, the first thing I would do is multiply the 15 across. So I get 15 sine of 50 over 12 is equal to the sine of angle B. All right, so I've multiplied by 15, divided by 12. We do that on our calculator. All right, so let's take out my calculator here. Let's see here, I've got 15 sine of 50. Don't forget to close your parentheses off because I got some more math to do. Divided by 12. I get this decimal, okay? And that will do the sine inverse of that answer. All right, so just come up, highlight that little guy, and insert it, and then hit enter. And I get an angle of 73.2 degrees. So angle B's measure is 73.23 degrees rounded to the hundredth. Okay? Oh, I'm a bad boy. I should have done this in the beginning. Guys, don't forget. I know I have three angles in this triangle. I have three sides. So let's fill these in. I was given that A was 50. I'm given that little a was 12 and that little b was 15, right? So that information is solid. We know that that can't change, right? Now that I found angle B, I get that to be 73.23 degrees. I can fill that in. But whoa, notice how that angle is bigger than the given angle of 50 degrees. Okay, so now that I found this angle B to be 73.23 degrees, I recognize from my rule that he's bigger than the given angle of 50 degrees, right? So I know that there's going to be a second triangle. Oh, what a pain in my angle side. I got to do more work. I know that I'm going to have a second triangle possible, okay? So I need to list out those same set of letters again for this second option. I still got another angle A, another angle B, an angle C. Side A, side B, and side C. Again, the 50 degrees can't change, the 12 can't change, and the 15 can't change. All right, so now how do I find this second triangle's information? Well, you have to use this angle B that I just found. To find the second alternate version of him, you're going to use the supplement of B. You always use the supplement of the first angle that you find. Now again, the word supplementary means they add up to 180, right? So if I take the 73.23 and I subtract that from 180, I get, what is that, 106.2 degrees. Right? That is the second option for angle B. So I get 106.77 degrees. And again, all you do is take that first angle you found, the 73.23, and subtract that from 180 to come up with this second option for him. Right? Okay, from here, now I just solve each triangle as if I always do. To find angle C, I add these two angles together, the 50 and the 73.23 right here. I'm going to add these two angles together right here, and subtract that from 180 to find angle C. When I do that, I get 123.23. Subtract 123.23 from that, and I get 56.77 degrees. Now that I have that, I can put these numbers back into this triangle here. I can say that, let's get rid of this. I can say that angle B was 73.23 degrees, and angle C is 56.77 degrees. And now I can find this missing side C. All right? Setting up the law of sines for angle C, I'm sorry, not for angle C, for side C, I would say that the sine of 50 over 12, again, you're going to use that same given angle and side, equals the sine of 56.77 divided by that little c. Again, to solve for c, I'd cross multiply, so c times the sine of 50 equals 12 times the sine of 56.77. Pardon my memory, but I forgot where I was at. I had... okay, that was just my alter ego talking there. So I was solving for side C, and I had come to this part of the equation. Now I divide both sides by the sine of 50 degrees to get C alone. And I type this into my calculator. And I get, let's see here, 12 times the sine of 56.77. Don't forget to close your parentheses off. Divided by the sine of 50. And we get 13.10. So this third side is 13.10. Okay, and so that missing side that we just found is 13.10. So that missing length is 13.10. Now, guys, that's only finishing off solving the first option of the triangle. Now I got to come down and solve for the second triangle. So the reality is, I guess I should draw a second triangle for you guys. So I want to come in here, and again, it's not going to be drawn to scale, right? So this is A, B, and C, right? A, B, and C. We were given that A was 50 degrees, little a was 12, and little b was 15. Well, again, now that I found this alternate angle, and again, how did I find this alternate angle? By taking the original 73.23 and subtracting that from 180 degrees. I get 106.77. And now I still have to find this missing angle C. And again, I can just add those two angles together and subtract from 180. 106.77 and 50 is 156.77. Subtraction from 180 is 23.23 degrees. So I found this missing angle here, 23.23 degrees. And now I can find that missing side C. Okay, to find that missing side C, again, I'm going to set up the law of sines using the first angle and side that I was given, the 50 and the 12. Set that equal to the sine of 23.23 over little c. Cross multiply, and I get c times the sine of 50 degrees equals 12 times the sine of 23.23 degrees. Dividing both sides by the sine of 50. I get c equals 12 sine 23.23. Don't forget to close your parentheses. Divided by the sine of 50. And I get 6.18, rounded to 2 decimal places. Okay, so that that third side is 6.18. And now I've solved both triangles. The obtuse version and the acute version. And that's how you get your triangles.